In this class, we will understand the mathematics of accessing two-dimensional array elements. And in this class, we will discuss the concept of row measure order formula. We are not going to discuss the column measure order formula because the C compiler always implements row measure order. And the formula for column measure order is also provided in this here. So I request you to understand the formula on your own. So you try to understand this formula on your own. Very simple to understand. We will try to make this as simple as possible. So let's get started with the concept by using an example. So here the same example that we have discussed in our previous class, I have taken this two-dimensional array. And what I have done is I have marked the size of row index and column index as mn. So because these values are used in the formula to calculate the exact address of the accessing element, we are using this m and n. The size, the row index is considered as m and the column index is considered as n. So let's get started. Here I am expecting, I am trying to access the element 1, 1. Means the first row element and the first column element. So the meeting point. So this is the element. So here this is the kind of visualization that we are having. Now what I am trying to access is, this is the element I am trying to access. 9 is the element. So 2D of 1 comma 1 means, so this is the element, right? First row, first column, the meeting point, this is the element that I am trying to access. So how the calculations are done if the compiler is using row measure order. So this is the formula. So the final outcome is the address. So now if you take this row measure order memory location, row by row we are going to calculate, and the address of 9. So what is the address of 9? It is 112. Okay, so the 4 locations 112 we are going to get from this location. So this is the address that we are going to get as the final calculation. Okay, so how we are going to get that, we will try to understand. So the formula is base address plus I into n plus j into size of element. So this is the formula. Now we will understand. So no need to remember any formula. And one more point that I want to make you understand is, based upon the element that we are trying to access, so that row index and the column index. So here we are trying to access 1 and 1. So first row, first column element. So the row index for accessing the element is considered as I. So these are the final sizes, right? 2 elements, 2 rows and 2 columns. M and N stands for. I is the element, the row in which the element that we are trying to access, and J is the element, J is the column in which the element that we are trying to access is existing. So here I is used for this element row index and J is used for column index. Okay. So now with this understanding, we will understand the formula in a very detailed way. So first we will understand this part, I into n plus j. What is this I into n? This complete part is going to get is, first we will understand this I into n. With this I into n, what we are going to get? So what we are going to get is, as we know, the elements are accessed row by row. So the first element is 7, the second element is 4, and the third element is 6, and the fourth element is 9. So this is the element that we need to access. With this I into n, what we are going to get is, how many elements are there? So what is our current row? It is 1, right? The current row is 1. How many elements are there above this current row? So that value we are going to get from this I into n. What is the value of I? I is 1. And what is the value of n? 2. So 1 into 2 is 2. How many elements are there above the current element? So the current row, above the current row, how many elements are there? There are 2 elements. So this is what we are going to get from this part of the formula. I into n, we are going to get the number of elements that are present above the current row. Current row means the existing value, the value that we are trying to access is existing in the current row, which is 1. Okay, so now what is this J? What is this J is, it is the number of elements to cross, the number of elements are to be crossed so that we can reach our required element. So how many elements ought to be crossed? One element has to be crossed in the current row. In the current row, in order to reach this element, how many elements ought to be crossed? One element has to be crossed. So now what is the value of J? The value of J is 1. Now with this total value 1 into 2 plus 1, which is going to be 3. So what we are going to get is, in order to reach our required element, I have to cross 3 elements, 7, 4, 6 are the elements to be crossed by me, so that I can reach the required element. So the element that we are trying to access. Try to get this point. So this part is the very important part in this formula. So we are going to get the number of elements that we need to cross is 3. Okay. So now into 4. So what is this 4 is size of each element. So as we need to cross 3 elements, so the size of each element is 4 bytes of space. How many bytes of space are required to reach this particular element? We need to cross 12 bytes of space. So that is what we are going to get from this, which is 3 into 4, we are going to get 12. And the base address is 100. So to this 100, if you add 12, we are going to get 112, which is the starting address for the element which we are trying to access. We are trying to access 9 and the starting address is 112. So you need to understand this formula in this way. So that is the simplest possible way to understand. What about column measure order? What is the formula used by the column measure order? Now can you guess? It is very simple. So it is base address plus j into m plus I into size of element. So now can you understand with respect to the discussion that we have made? So for example, if you want to reach this element, how many elements ought to be crossed? So again 3 elements, but the way in which the column measure order. So how the column measure order is done? So this is how the elements ought to be crossed. So 3 elements ought to be crossed. You try to understand the formula. So this is the hint that I am giving you. So you try to understand this formula on your own so that you can get better understanding of this concept. So that's it for this class. In the next class, we will see how the elements can be assigned onto the memory by the user. So that we will try to for the 2-dimensional arrays. So that we will try to understand in our next class. So that's it for this class. See you in the next class.